What would you like to know about neuronal mimics? Sure. Neuronal mimics are conditions that resemble neurological diseases but aren't actually caused by primary neurological issues. They can be tricky to diagnose because they mimic symptoms like seizures, strokes, or other neurological disorders. What specific aspect are you interested in? It sounds like you might be describing a phenomenon where you feel like you're perceiving interactions or presences similar to having friends, even when they're not physically there. Is that what you're experiencing? It sounds like you have a strong bond with your friends and their presence feels very real to you, even when they're not around. That connection can be comforting and supportive. How does it make you feel when you sense their presence? That's wonderful. Feeling connected to your friends, even when they're not physically present, can be really comforting and uplifting. It's great that you have such a strong bond with them. That's an interesting way to describe it. It's like your mind is creating a comforting echo of your friend's presence. It sounds like it brings you a lot of joy. The brain's social simulator, how neurons mimic interaction. Humans are intensely social, and our brains can simulate social interactions even when we're alone. In fact, the brain is often described as a prediction machine, constantly generating experiences internally and then checking them against reality. As neuroscientist Anil Seth puts it, our experiences are the content that the brain predicts from the inside out, anticipating what is in the world. This predictive processing means that neural circuits can create a kind of controlled hallucination of reality, including the presence or actions of other people, which is normally kept in check by sensory inputs. Through mechanisms like internal predictive models, memory recall, and social cognition networks, neurons learn to recreate social experiences in the absence of others. This ability helps us practice and navigate social life, but it can also blur the line between imagination and reality in altered states or disorders. Predictive processing, internal models of social interaction. Our brains continually predict and simulate the world. In social contexts, this means we form internal models of other people's minds and actions. Neuroscience research shows that some neurons actively mind read by simulating what others might do. For example, scientists discovered special simulation neurons in the amygdala, an emotion center, that fire as if reconstructing a partner's decision making process, helping an animal predict a social partner's intentions. Essentially, the brain can run a little virtual other, modeling someone else's choices or reactions as a way to anticipate and respond appropriately. This internal social modeling is an extension of the brain's general predictive coding strategy, which tries to forecast incoming information and only corrects errors when reality doesn't match the prediction. Such predictive simulations are normally grounded in reality. Your brain expects someone to speak, and then they do. But if sensory feedback is weak or absent, the brain's predictions can take over. In extreme form, this can produce hallucinations, the perceptual experience of a social presence or voice with no external input. Cognitive models of psychosis suggest that auditory hallucinations may result from inner or subvocal speech being misidentified as externally caused. In other words, the brain's own generated speech, your inner voice, is predicted so strongly or tagged so strangely that it feels like someone else's voice. This fits the predictive processing idea. The brain's top down predictions trump the lack of actual sound, creating a vivid false perception. Generally, when the brain's internal model overweights prior expectations, it can produce social hallucinations, like hearing voices or seeing people, until a reality check kicks in. Memory recall and social cognition networks. Another way neurons simulate social experiences is through memory and imagination. Remembering a past social interaction can reactivate the pattern of neural activity associated with it, letting us relive or rehearse the experience. Notably, brain imaging shows a strong overlap between autobiographical memory, remembering personal events, and social cognition, thinking about others' thoughts or feelings. In fact, recalling your past and inferring the thoughts and feelings of other people, mentalizing, share a neural substrate. These processes engage a common network of brain regions, including parts of the temporal lobe, parietal cortex, and prefrontal cortex, as well as emotion-related areas like the amygdala. This network is a core of the so-called default mode network, which is active during daydreaming, envisioning the future, and pondering social situations. It makes sense that when you imagine a conversation or reflect on how someone might react, you're activating areas similar to actually interacting with them. Memory provides the raw material for social simulation. If you've experienced certain interactions, your brain can replay and recombine those memories to simulate new scenarios. For instance, you might rehearse an upcoming difficult conversation in your mind, essentially running a mental simulation of a dialogue. The brain's motor and sensory systems also participate in imagery. Remarkably, studies of mental rehearsal find that imagining an action can produce brain activation in overlapping areas as performing the action for real. Similarly, imagining a person's voice or facial expression will engage auditory or visual regions. Because neurons that fire together wire together, each internal replay can strengthen those neural circuits. In this way, neuroplasticity enables the brain to learn from simulated experience. Practicing social skills in your head can make you better prepared the next time they happen in reality. Neuroplasticity, learning social interaction by simulation. From childhood through adulthood, our brains adapt to social experiences, even imaginary ones. Children often have imaginary friends, and far from being fake, these companions reflect a child's brain flexing its social muscles. The child's theory of mind network, understanding others have independent thoughts, is hard at work when they converse with an imaginary friend. Through such play, neurons encode patterns of interaction, preparing the child for real relationships. The mirror neuron system is another example of built-in social learning. Mirror neurons fire both when watching an action and doing it, effectively allowing the brain to imitate and understand others' actions internally. This system likely develops through experience. Babies who see people make facial expressions will mirror them, tuning their neurons to map self and other. Over time, this coupling helps us intuit others' emotions and intentions. Our brains can conjure imaginary social partners as a learned coping mechanism. Through deliberate practice, tulpamancers create a tulpa, imaginary friend, who eventually talks back, providing companionship in solitude. Image, a woman sits with an imagined companion, transparent figure, an illustration of the brain generating a social interaction when alone. In extraordinary cases, adults can even train their brains to hallucinate a friendly presence. One striking example is the phenomenon of tulpamancy, where practitioners intentionally cultivate an imaginary companion, a tulpa, through intense visualization and meditation. Over months of daily practice, focusing attention on an envisioned personality and imagining talking to the tulpa begins to act autonomous, eventually speaking in the person's mind without conscious effort. Researchers describe tulpas as imaginary companions conjured through thought-form, meditative practice, essentially a benign hallucination that the creator knows is self-generated. Why do people do this? Often to relieve loneliness or to practice social interactions in a safe way. In other words, the brain's social simulator can be harnessed as a tool. Neurons learn to generate a vivid, safe, comforting social experience when real others are absent. This underscores the incredible plasticity of the social brain. It can adapt to prolonged isolation by creating virtual friends to fill the gap. And unlike psychotic hallucinations, Tulpas are usually experienced as voluntary and positive, coexisting with normal mental health.